Hey everybody, thanks for joining us today. This is SketchUp Live, episode 5. My name is Josh, this is Aaron over here.
Hey guys.
And today we're talking about 3D printing with SketchUp. Before we start, let's say hello to the director, Matt, behind the camera there. And producer, Michelle, right over here.
And monitoring your comments online, we have a couple of our knowledge team, Ty and Lizanne, will be there answering questions if they come up.
So yeah, we're talking about 3D printing today with SketchUp. I'm going to stop talking because you look kind of excited about this one, Aaron.
I am. I'm stoked. I love 3D printing. I think it's an awesome technology, and I love that SketchUp can be such an integral part of 3D printing and 3D design. So we're just going to jump right in. I'm going to go ahead and start by walking through a couple things. What we're going to look at first is, what do you need in order to 3D print? So obviously, first thing we need is software to make a 3D model. Ideal software for this is, of course, SketchUp. In addition to creating a 3D model, you're going to have to get it into the printer somewhere. That's where slicing software comes into play. Splicing software takes that 3D model and breaks it down into slices that the 3D printer is going to create. This is something that falls outside of what we'll be looking at today. We may kind of pass the buck on a couple of things to say that is something that the slicing software will do, but usually this is something that comes with or is recommended by your 3D printer. So that's something that ties in real closely with the hardware. And then finally, of course, you do need a 3D printer or 3D printing service. Everything we're talking about here can be done on your own, your desktop printer. You can actually print, or you could actually take these files we talk about creating and send them in to be 3D printed. On top of that, when we go to talk about SketchUp, what do you need inside of SketchUp? There are a couple extensions you're going to get. The first one is a must-have. You have to have the SketchUp STL extension. So this is how your 3D file gets turned from an SKP file into an STL file, which is what's needed for 3D printing. And then finally, this is a recommendation, not an absolute requirement, but it is something you're going to want to have, and that is Solid Inspector 2. We'll talk about that and actually show a little bit of that coming up shortly, but it is definitely easier to create 3D printable models with Solid Inspector than without it.
Yeah, so that term solid is important here. So what is a solid when it comes to SketchUp? So some of you may know this, but SketchUp is inherently a surface modeler. So you can see here when I start drawing, give it a few seconds here to catch up. I'll grab the line tool here, draw a few lines, and you can see when I complete a closed loop of edges, I get a face that fills in. So SketchUp is not a solid modeler, it's a surface modeler, which means there are some things we want to pay attention to make sure that our output from SketchUp is considered a solid. So you can see here, if I select all the geometry here in this shape, and I'll open up the Entity Info panel here. You can see it tells me 26 entities. That's not so useful right now until we group this. So if we group this geometry, we'll have a little bit of more useful information. So I'm going to right-click on that selected geometry, choose Make Group, and you can see that it now says Solid Group, and I actually have a volume output here. So it gives me a little bit more information. If you make groups in SketchUp, you might just see it say Group without a volume, but this is actually considered a solid, so it has Solid Group in the name, and there's a volume.
This is probably one of the biggest things that people struggle on. They create geometry, they go, I know it's closed, there's no holes in it, there's nothing else bad about it, but if you don't group it, then SketchUp can't recognize it as a solid. So it does have to be put in a group or a component. Either of those containers will work, but it has to be in a container in order to be considered a solid.
So let's take a look at that over here at this geometry. So let's say we're about ready to print. We've got something here. This looks kind of like that SpeakUp device.
That looks remarkably like a SpeakUp I've seen before.
Let's say we wanted to print one of these.
That's a good-looking model. I'm just going to go on a limb and say that's
yeah.
good stuff.
Aaron drew this, obviously.
Oh, I didn't want to brag or anything.
So it looks like we're ready to print, looks good, but actually there's a few problems here that we want to take a look at. And I could zoom around, inspect it myself, take a look, but the extension that Aaron mentioned makes this a little bit easier. So what we're going to do here is go to, I already have this installed, I'll show you what the page looks like on our extension warehouse. Solid Inspector 2 is the name, as Aaron mentioned. And this is, I've already got it installed, but that's what it looks like there on our extension warehouse. So back into SketchUp now. That lives in the Tools menu, solid inspector. And you can see here I need to click on this group first. And it looks like I've got two issues to take care of here. I can choose tab to take a quick look at what those two things are. I've got a stray edge and a hole in the corner. So the stray edge I can actually fix just by clicking on fix here. It'll remove that stray edge. That's nice. The other one, the hole, I'm going to actually close the extension now that I know where this is, and I can just quickly heal this myself, draw that in there, erase that edge. Looks pretty good. But Aaron and I both recommend actually running the extension another time to make sure that there's nothing else that we didn't see the first time, because we ran the extension on a solid, well, it wasn't a solid, a collection of geometry that was not considered a solid in SketchUp. So now that it is a solid, if I run that extension again, I do have reversed faces are being pointed out, which we didn't see before. So if I choose tab now, or press the tab key, it's circling something there in the back. Let's take a look and see what's going on. So it looks like it's pointing out a reversed face here on the back. So let's right click, reverse that so they're all facing the correct way. And then now we're going to run it one more time. We want to get a nice happy face out of this extension. So let's take a look, click on this. Hey, it looks pretty good.
That's right. You want to keep running it until you get that smiley face. This is available through the extension warehouse, and it is a free extension. So I recommend if you're doing any kind of 3D printing or any work with solids at all, whatever that may be, you definitely want to get a copy of that and get it installed, because it makes it a lot easier. Like Josh showed, some errors can be fixed automatically. Not all of them. There are some that will come up that will require you to dive into your model and make some fixes, but a lot of them can be fixed just by hitting a button. In fact, sometimes you get lucky and there's a fix all button at the bottom and magic happens and you have a solid. So,
but just like with real magic, be careful.
That's right. Public service announcement right there. All right. Well, with that, let's go ahead and hop into another model we'll take a look at. All right, so right here I have a model of a robot. This is we've actually seen this a couple times. This has been on some skill builder too, and it's actually standing right here as well. This is a 3D printed robot. So when I modeled it, I created it in groups, kind of in place. This was the way I wanted it to all look when it was finished. What I created, though, my actual output for printing, was those components in groups laid flat as they'll actually go to the printer. So these pieces, I obviously wouldn't want to send it to the printer standing up like this, because it would take a ton of support. All the pieces would be separate. It would be a mess. This right here can all be grouped together, export as an STL. So I go File, Export STL, and I can send it out to my printer. An important thing right here that I want to keep in mind is this bounding box I want to make sure is smaller than my print bed. I was printing this on a fairly big printer, so it all fit in one print job. But if your print bed is smaller than what you want to print, you'll have to break it into multiple print pieces or print sessions.
So that's a good point to talk about now, that the print bed does matter, the size of your actual printer dimensions, the print bed. You may have noticed if you go to SketchUp and you're choosing a template, or you're prompted initially to choose a template, you'll see here there is a 3D printing option. So let's cruise into that and take a quick look. I'll do a File, New, and you can see here that we're presented with some basic geometry that happens to be the same dimensions as a very particular 3D printer. Of course, if you had different dimensions, you can delete that, maybe change the dimensions here of this box, and that will allow you to customize your geometry in SketchUp to match the physical print bed that you might be working with.
Right, so that cube kind of represents the full print geometry, so not just the bed, but the actual vertical extent too. Yeah. So it's not a requirement. You don't have to, in order to 3D print, you don't have to use the template or anything, but it is a nice option because it does show you, where should your print fit in order to successfully 3D print. Some I want to throw out too. We are hoping you guys have lots of questions, so get those questions in here, type into Facebook. Any questions you have regarding 3D printing, we'll do our best to answer these as we continue running through here.
Yeah, we should have lots of time at the end to answer questions.
So something else to point out here, so as Josh was showing, you could adjust that volume for your actual printer. Once that's done, you can then save it as a template and actually use that anytime you're going to create a 3D printing model.
And that's pretty easy. You just go to File, Save as Template, and then you're prompted to give it a name and that template will be available to you anytime you want as a custom version that you made.
So one of the things you want to make sure you don't do is take that geometry that Josh has on the screen and export it to your printer. This could be done a couple different ways. One thing is Josh could take that and actually lock it, which is a nice thing because then I'm not going to accidentally select it. I'm not going to merge geometry with it. It's going to stay isolated.
So you can't interact with it in SketchUp unless you right-click and choose Unlock.
The other thing that we want to look at is when we actually go to export this geometry to the printer, when I go to File, Export STL, the first checkbox right here is Export Only Current Selection. If this is turned off, then everything in my model is going to go out to the STL. I want to make sure that Export Only Current Selection is turned on. That way, only the piece I pick is going to go out. That's real important. The other thing in here they want to point out is this is in millimeters. That millimeters is what the printer that I'm using is going to expect, so I'm going to make sure to export in millimeters. It's kind of funny because being a brainwashed American coming up in the architectural field, I think in feet, inches, and sixteenths, sometimes 30 seconds if I'm getting really small, but I don't think in millimeters very well. But when I go to 3D printing, I do start to kind of find myself thinking that way, just because those are the units that most printers actually recognize. So something to keep in mind. Fortunately, we all know, it's real simple to model in whatever the unit of your choice is, and then you can always come into Model Info, and in Model Info, change your units right here from inches, sixteenths into millimeters. It's real easy, and I can do that. I don't have to do that at the start of a model. I can toggle back and forth, maybe change it as I'm exporting models, that kind of thing.
So it looks like, Aaron, you've got some interacting elements there that once printed will be combined together. Can you talk a little bit about how you think about clearance, and friction that you might want to consider later on?
Absolutely. So this is a good example of how 3D printed parts can work together. So I'm going to look at this chest section of the robot. I'm going to take this front piece and I'm just going to kind of slide it out of the way. So you can see right here a couple things are happening. These little round pieces are actually going to swivel inside of these half circle openings. So that's going to actually require some clearance right there. The other thing is, as these two boxes snap together, you can see I have a cavity on this side and a little peg coming out this side that's going to nest in there. If I zoom in here real tight, I can see this peg is actually offset from the exterior wall. If I check that measurement, it's actually, I got to go do exactly what I just said I needed to do and swap this back over to millimeters. And this dimension right here is 0.15 millimeters. I found that for the type of printing we were doing, which is PLA printed on a 3D printer, that about 0.15 millimeters gave me just the right amount of clearance so that this peg would fit into this space and it would still be snug. The issue that comes up a lot of times with this printing is you have to be mindful of the material you're using. Printed extruded plastic is not going to be perfectly exact every time. There's going to be a little bit of warping, expanding, contracting, so it's going to be a little bit off. It's not going to be absolutely perfect. So a 0.15 millimeter gap seemed to be about right that I could get these nested pieces to push together and lock together. So the actual final product, there's nothing else holding it together other than the friction of those little clips. Speaking of them, there is something else I want to point out right here. So I have these half circles that, like I said, nested these swivel pieces. So originally I had them just modeled like this. Just a simple half circle. And what ended up happening, of course, was because this piece is going to overhang in the printer, it has to print up support material to kind of sit underneath here. It can't just print this out into space. It's not a big deal. That's something the slicer does automatically. It goes in there, puts that extra plastic in there, supports it. It's fine. It actually is no extra work at all. But what I found was, so I had 8 of these pieces just between these two boxes. Over here I had a couple more. What I found out was the amount of time and plastic it took to put those supports in there was actually less than if I just changed the model and brought this piece down to the ground. Again, not a big deal. It wasn't a huge amount of plastic or hours of extra printing, but it was actually quicker and more efficient to do that. So it's something else you want to keep in mind as you go through printing is, you know, how is this model actually created? Is this optimized for printing or not?
Yeah, so each model you make, you kind of collect those tips, and as you draw, you can make things a little bit easier for yourself in the 3D printer, just knowing those little tricks that you kind of pick up along the way.
Exactly. So it's just printing can be an iterative process. You learn a little bit more every time you do it, and then hopefully next time you do it, it's a little quicker and easier. Some other things that actually ended up changing as I went through and modeled were some of these arm pieces. So here I have these pieces that they interlock and actually have screws going through the holes. Interesting note there too. I did model these screw holes smaller than the actual screws that were going to be used, and that was intentional. I've done this before where I have, you know, a manual way of connecting these two pieces, something outside of 3D printing is going to hold it together. And what I found is, again, because of the variance in the material, it's really hard to get a real perfect, specific screw hole. So what I ended up doing was modeling it small and then just drilling it out. It's a little extra step, but it gives you a nice clean hole that you can put a screw through or something like that. So these are intentionally modeled smaller than the actual screws I used. So what I was looking at was some of these pieces. When I printed this first batch, this is all the pieces for the robot, but when I first printed, a couple pieces didn't come out so good. Specifically, these pieces right here. So these 4 pieces printed perfectly. What happened was support material came up like this, then this nice dome shape was printed, 3D printed, everything looked perfect. Over here what ended up happening was on this side they were supported perfectly. On this side where this kind of half circle comes underneath, it didn't print so well. The material didn't stack right. It kind of looked like it got squished or run over. All 4 of these just did not look good on the end. So what I ended up doing was making a kind of a revision. So I actually broke what was one piece into 2 separate pieces. So I hollowed out this piece, put a little plug that would fit into this hole, again, 0.15 millimeter clearance around the whole thing, and this way I would get support material underneath both of these dome shapes.
So I like this, what you've done here, because you have joints that aren't actually visible joints. They're sort of behind the scenes joints that are just made because of, you know, how you know it 3D prints. So it's a joint that's sort of hidden.
Yeah, exactly. So this ends up nesting together. You'd never see it in the end. It actually ends up looking like one piece. But because of the orientation, everything printed well, and the end pieces looked real nice. I ran into a second issue with these swivel pieces. In the first print, I actually printed them. I tried a couple different things. I tried printing them laying down. I actually ended up grabbing them at one point and tried printing them standing up. I had problems both ways. Laying down specifically, I had a problem printing this circle vertically. So I had the same problem. Printing a circle on end like this ends up creating some ugly geometry on the bottom half. Top half stacks up great, but because the way that the slices are going across, I ended up with some bunching and some overhangs. It just didn't look good.
Hey, would you mind answering a quick question here? Because
Sure.
you're kind of in some curves.
Yeah,
curved
absolutely.
things. There's a question that says, how do you create a curved element? So you've got some curves happening there, some
Sure.
Geometry that's not rectilinear. Can you show how you made some of that?
Yeah, absolutely. So this stuff was all made, excuse me, was all made with SketchUp standard commands. Of course, there's a ton of awesome extensions out there, which I know we're not talking about right now, but there's a lot of good extensions out there to do things like curves or sweeping volumes and that kind of stuff. This was all really made with simple commands. So one of the things I used, and I use quite a bit, is like for this half circle, I use a half circle like this, and then I'll come in here and create another circle like that. And then what I can do is break that and then use one of my favorite tools, which is Follow Me.
That's a good one.
So what I can end up doing, actually, let's take this a little bit longer. I want to make the whole shape. So I'll come down here like this, and I'm going to take this, bring it back over here, and I'm actually going to swivel it 90 degrees. And I'm going to place it right here on the end. So what I ended up doing was select these shapes, follow me, and just sweep that around. I was close. Flew too close to the sun. I was demoing without trying first. So this one would require a little bit of cleanup. Not too bad. But yeah, that gives me that initial shape. A little bit of cleanup to happen inside there. But that would actually give me those round shapes. And again, this is something you want to keep in mind as you're printing, because as these stack, if I print it laying down flat like this, the layers are going to stack and get smaller and smaller and smaller and smaller. I'm going to have like a nice tapered volume coming up. It just prints a little bit different than, say, a rectangle or something like that. Real easy to visualize how that's going to print and stack. So it's something you want to be considerate of. Like I said, that's what I found out here was I want to make sure that that volume, that rounded shape is on the top, because that's the way the layers are going to stack neatly. So hopping back over to these pieces, like I said, I found out I could not print them laying down because it did not respect the circle geometry very well when I printed. So I tried printing them standing up. They actually came out looking real nice. I had some support material in here I had to break out, but I ran into a new problem. And this has to do with what I call the grain. So again, as I'm printing, this is getting laid down in layers. So as it prints this middle peg, for example, it's printing a circle of material. Circle, 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 circle. So what ends up happening is like a stack of coins, and that's the material for that layer. So what ended up happening was when I actually put this in the robot, so I put it in here, this ended up being a really weak piece. And if there was any friction when I tried to turn the swivel, it actually broke between the laminations of the print. So that became kind of an issue, because he's basically held together by 7 of these swiveling pieces. So what I ended up doing was finding a way to print so that the grain went the direction of the peg, but at the same time printed my half circles properly. So what I ended up doing was printing this in 2 pieces, and then I just glued the 2 pieces together to actually create that final geometry.
So in a way, it's kind of like wood grain. Sometimes it does matter which direction they're using the piece.
Yep, absolutely.
So it's probably obvious by now, but if you're new to 3D printing, you might be noticing that it is an iterative process, trial and error, experimental. So if you're just getting into 3D printing with SketchUp, kind of approach it as your first print's going to give you some information, and it's going to get better and better. And,
some information. That seems like a politically correct way to state that. Yeah.
Some useful info. Yeah.
You'll get immediate feedback upon printing.
Yeah.
For sure. Yeah. It is like you use the term iterative process, which I think is really good, because again, having printed many prints over many years, I still end up trying to come up with the ideal way to print this stuff. So there's not an exact way to, well, I'm sure there is an exact way to do it, but
yeah,
doing this kind of as a hobby, I haven't come up with the exact perfect way to make it happen. It's something that I kind of refine every time I print something. So reminder, please hop in here, ask questions as we go through here. We've got a couple more things we're going to talk about, but at this point, it's kind of your show. We'd like to hear what you have questions about, what you'd like to see for 3D printing, or anything related to 3D printing in SketchUp.
We've got one question here, I think, asking if you work out.
I don't, but He-Man does, so I respect that. Yeah, I've got a couple other questions. Robert's asking, how do you model multiple prints, such as, I can't see, the screen's covered up.
So I guess multiple materials, maybe split that up in different models?
Multiple material prints. Oh, printers with a washout support material. So what ends up happening, the way this works, there's a couple different ways to do it. So if you're actually doing something like a multi-headed printer, and you have 2 pieces that are going to come together, say this is red and this is white, but I want to print it as one piece like this, what you'll end up creating is actually 2 separate STLs. So I'll create my red STL, save it, same my white STL, and then I will align them and assign those prints to separate heads on the printer in the print software. So it's not, as far as SketchUp's concerned, it's 2 separate models completely. And we just actually nest them together in the slicing software when you prep for output.
So for those who are just joining us, perhaps halfway through, please ask questions. Toss them in the comments there, and we'll get to them.
Yeah.
We got a bit of a choppy stream, I think, so
Yeah.
we want to make sure we're
We've been hearing about it.
repeating the question things. We want to answer your questions.
Yeah. So one of the questions we get, and I'm just going to head this off because somebody will ask, is what do we suggest for 3D printers? And it's kind of like asking what car's best. Everybody has opinions. I don't think there's an absolute answer. It really comes down to what you're going to print and how much money you have to spend on it. If it's a hobby, it's something you want to just kind of do on the side for fun, you probably want to spend a few $100s, less than $1,000. If it's a professional thing where you're actually going to be charging for what you print, then you're going to want to spend a little bit more money. So that's kind of a big piece. We have a couple printers. We have a lot of printers behind us. At the end here, this one with the orange hood is a Formlabs printer. It's more of a high end, but it's going to give an incredible high quality print. So that's something, actually keep an eye out because we're going to have some guys from Formlabs on Facebook Live next month, and we'll talk about that specific printer. And you guys will get to see exactly what it looks like when it prints. But high quality, it's also a high end printer. That's more of a professional tool. Just to the right next to that is our Prusa, a newer printer we just got a hold of. And this is a more economical printer. It is under $1,000 to get one in your house, office, whatever. But it is a great tool to do little prints, do extruded prints, prototyping, that sort of thing. It's easy to use. It's quick to set up. So again, unfortunately, don't have an absolute answer that says this is the printer for you, but there's a lot of options out there.
There's a question from Michael. He asks, what version of SketchUp do you need for 3D printing? And you can actually do 3D printing with SketchUp Pro or SketchUp Make. SketchUp Make is the free version. And the thing that you need is the extension that Aaron mentioned earlier, so the STL extension. So whichever version you're using, make sure you go grab that extension because at the very least, you need that to export an STL file.
Yes, absolutely. Yeah, so the version of SketchUp that you're running is pretty much the answer. But like Josh said, the STL extension is required before you can really do anything there.
Arnold asks, do we have a tutorial on YouTube? So for those that don't know, we have things called skill builders on our YouTube channel. So I think Aaron did at least one on 3D printing, or maybe it was a blog or something, but we'll be adding more of those in the future. So take a look at the skill builders.
Yeah, check out our YouTube channel. There's a lot of stuff up there. I'm sure, I can't think of anything specifically. Well, this will be up here. In a couple weeks, we'll be on YouTube with this. So then yes, now probably. But yeah, take a look because there's a lot of good stuff up there. James asked, can 3D printing in SketchUp build in smoothness to the printout model surfaces if you have low segment count in curved surfaces? So what James is talking about, go ahead and hop in here and show an example. If I come in here and draw a circle, when I go to draw a circle, down the lower right corner, it's going to ask me how many sides I want to put into this circle. So I'm just going to draw a circle with 12 sides, just to show you how this works. Okay, there I have a circle. If I pull that into space, I get what looks like a nice smooth shape. But this is actually kind of a rendering effect that SketchUp is adding. If I look at my hidden geometry, these are the surfaces that are going to actually print. So if I print this right now as a solid, it's going to print not as a perfect circle, but as a 12-sided polygon, basically. I can, as I come in here, if I know I'm printing and I want this kind of a big print, I want it to be smooth, I can increase the number of segments I put in, say, a circle. This one I input as 48 sides, and that's going to print a lot smoother looking. There's not a function inside of SketchUp that says smooth this out automatically. There are extensions out there that do things like give you tools for organic modeling to make a smoother model from the ground up. But the fact is, STL files are made up of connected surfaces. So there's nothing in an STL file that says this is a nice, smooth, soft piece. What's happening is it's actually being made up of very small surfaces. So everything that's in an STL file is triangles. It's all triangulated mesh. The question is, how fine was the geometry that was used to create those triangles?
Looks like Aaron says he has a problem with curves or circles printing with flat edges.
Okay. With flat edges.
edges.
Not 100% sure what that means, but I think what you may be running into is kind of what I was talking about before. If I take this volume right here and I print it standing up, I will actually have fairly smooth geometry. If I take this whole thing, I'm going to make a group real quick. If I was to take it and print it on its side like this, it's going to come out weird. Stuff's going to happen.
Just in case he's talking about segmentation, you could try making a circle with, change the. Can you show that? I think you mentioned it before, but
Yeah. So if you didn't catch it, when you do draw a circle, you can change the number of sides. In fact, before I extrude this, I can actually select this and. Nope, I can't. There.
I think
There we go.
For 3D printing,
I can actually select the edge side and type in the number of sides I want to have on here. So I could bump this up to like 100 sides.
And for 3D printing, this is totally okay. This is something that you want to pay attention to, though. If you have a large SketchUp model, the more circles you draw with higher segment counts, the more complex the resulting geometry will be. So keep that in mind.
Yeah, absolutely. So yeah, if you're talking about flat sides on the side, that's just a question of resolution of the circles. If it's an issue with printing, laying circles on the side, that's where I went through and I actually split my geometry in half horizontally, because circles printed from the side can build up from the bottom, but it's hard to model from the circle up, basically from the print bed up. I think it just came up and told me 399 was the max number of segments I can have on circles. Aaron's asking what's the max number. I think 399 is the max, it said, but you're going to want to be careful, like Josh said. If you get 399 on every circle and you have several circles, you can end up with so much geometry that it actually is an impairment to your modeling. It's actually going to run really slow at that point.
And
if
in
you
some
have a lot
cases,
of
it could be unnecessary, but if you're really trying to get something smooth, that's the way to go. Just up that segment count and see how it looks.
The other thing to remember is you're going to model for the technology that you're using to print. So if you're using an extruder print head, it's not going to have incredibly super fine geometry. You're going to actually see the ridges and that sort of thing. So some people worry about getting really smooth geometry when it's really not that necessary. It's just something to be mindful of. So again, my recommendation is always try it. Print it. How does it look? Do you need to modify? You need to go more or less? You can always do that. Iterative process, like Josh said.
Yeah, keep those questions flowing. See if you got any new ones there.
Question about this session being recorded. You got that one?
It will be. Yeah.
That's the answer. Yes.
That's a good question too, because I think we briefly mentioned, but it'll be on YouTube as well.
Yeah.
We have a playlist there that's a SketchUp live playlist. And this is episode 5.
Yeah. You can always get back to it in Facebook, too. If you watch it in Facebook, you'll actually see the comments come up, but it will be recorded and put on YouTube as well.
This is a fun question here. I'll answer this one if you
right.
switch me over. Gabriel asks, how can I get lines in different colors? So this is actually going to be done with styles in SketchUp. So I'm going to zoom in here. Let's go to this one here. And I'll open up the Styles panel, Window, Styles. And let's close this down a little bit more. So if I go into the edit mode for a style, so you can see here I have 2 styles in my model right now. If I click on one and I want to edit one of those styles, I can choose to edit the edges first. So these are different categories that have different attributes that you can change. And if I go to color here, I can do by material, by axis. So if we click around, you can see here, let me jump over to this first scene. So color right now is all same. By material, by axis, if I click on this color swatch there, I can also change them sort of globally so that they all have the same color. So this could be useful for various reasons, but that's done in the Styles browser or the Styles panel.
Perfect. That is, if that was a question you're asking for. If you're asking about actually getting the printed lines different colors, that's something else. I don't know what the answer is to that one.
That is indeed something else. What else we got there?
Aaron asked about importing DXF files into SU Make. That is a pro feature. So that is one of the things that we have in our SketchUp Pro software that's not part of Make. So Make is, of course, intended for home and hobby use, 3D printing being part of that umbrella, DXF files being part of the Pro usage, which it requires the Pro software. All right, what else we got?
Yeah, we're waiting for more questions to cruise in. Anything else you want to show? Oh, the thing you're using was 3D printed.
Well, as a matter of fact, we just a quick story about 3D printing, because we actually ended up using this in the office. We have these very nice compostable coffee cups that we use in the house, but they don't give a whole lot of insulation. So what I ended up creating was a little handle that actually holds your cup for you. This is kind of nice because we ended up with a original prototype that was quite a bit bigger, heavier, clunkier. They worked the same, but we were able to go through kind of an iterative process again to optimize the handle so that this was printed with less material, printed a lot quicker, but not only that, it prints without any material support at all. So the arc of the handle is such that it doesn't actually need any support as it builds up. The only support comes into this little clip right at the top, but other than that, the whole thing is printed without support. Again, not the first print, but the 5th or 6th time actually got it to that point. So
yeah.
Again, just one of those things that it's nice. This is where I geek out on 3D printing, because it made something that I don't know how I would have built something like this. I mean, in a wood shop, or I don't know what would have happened, but
or just not have made that and
probably
had a warm hand with your hot tea.
Yeah, well, yeah, I guess if you're going to live like a savage. But yeah, kind of a cool example of real life 3D printing in our office.
How does it stand up to a hearty cheers? That's pretty
It's
good.
not very, it doesn't sound good, but it works okay.
Okay.
All right. Well, we'll keep running. If you guys have more questions, keep bringing it in. But I did want to announce something that's kind of cool that's going on. Speaking of 3D printing, we are doing a quick as in it's going to be short, 3D printing contest. So what we're going to ask you to do is design your own 3D printer, or scratch that, rewind, try again. We're going to ask you to design your own spinners using SketchUp. So I don't know if you know, but do you play spinners a lot, Josh?
I've not heard of these. Let me. How do you?
You got it,
Looks
more or
like
less.
You
That's
do
right.
better than me.
So it's actually kind of a magical device. It reduces stress and fidgetiness.
Yeah.
A vortex gets created when you spin it that actually pulls negativity out of your body. It's amazing. They're cool little things. They're fun. You guys have seen them all over. You probably designed your own. So what we're asking for is you to come in and design your own spinner. So up on the 3D warehouse, there is,
Oh, there we go.
there we go, a template. And it looks like this. It has 2 objects in it. This is a bearing and the nut. So what we're asking you to do is design a spinner using, of course, the bearing in the middle, and then 2 or more nuts as the weight. What we're going to do is you're going to actually design it, upload it to 3D Warehouse, and tag it, as I have this one tagged, with the term SketchUp Spinner. So you get that up there, tag it with SketchUp Spinner. We have 1 week, so to the end of the day on the 28th is next Wednesday, to upload these. What we'll end up doing is we'll go up and we'll take a look. Anything that, again, uses our bearing from the model and our hex nut from the model, design in SketchUp. If you pull it in and it looks like it came out of some other crazy software, then we might have second thoughts. If it's cool enough, I don't know, we'll see.
Also, should they add some things to the description? That will be helpful.
Yeah, if you want to tell us about what it is, what it means, that kind of thing, we're just going to look for the best spinners we can find. What we're going to do is we're going to take, say, the top 10 coolest looking spinners, we're going to print them out, and we're going to spin them.
And see how much stress.
This is the
is pulled
judging.
away.
That's right. I feel better.
Also, contact info, right?
Yes, absolutely. It is important. Actually, I would go with the term, I don't use the term imperative very often, but you do have to have your contact info in your profile on 3D Warehouse. It's not a required field, but you do want to at least get your email address in there, so if you win, we can tell you won. So winners will get this right here, 3D mouse. Product shot.
Or a box with the 3D mouse on the cover.
You won't know till you get it.
It's pretty heavy. There's one in
Yeah.
there.
Or a rock in a 3D Connect box.
And that's, if those that don't know what that is, it's one of these guys.
Yeah, that's what Josh is using right there. And then a handful of runners-ups will get some additional stuff, including the sought-after, desired SketchUp socks.
Limited edition.
That's right. We print these once a year or so. These are this year's edition, and I gotta say, these are probably the best socks that we've ever done. Would you go with that?
They're great.
I'll get some pushback from the office of that. No, the black ones are better. But I think these were really good socks. You'll get that, and maybe a couple other fun things, stickers or something like that. But you can only get that by designing your spinner in SketchUp, posting it to 3D Warehouse, and tagging it with SketchUp Spinner. So to get that template, again, just go to 3D Warehouse, search for SketchUp Spinner, all one word, and right now it's the only file up there. So we'll be taking a look, like I said, a week from now, and get the best spinners we can and give you guys some prizes for it.
Take a look at your spinner?
Oh yeah, absolutely. So this was a spinner. Again, we created it using the hex nuts. I just kind of kept that design through here. And fun thing about this was actually printed in NinjaFlex. We had some NinjaFlex and we tried it out, and it turns out it makes a pretty cool spinner. The spinners we print will actually print with PLA, so we'll print it just with the standard plastic. But this is kind of a fun one because I don't know, because it's squishy. I don't know, that makes it cooler.
Yeah.
I guess.
Might absorb more stress. Who knows?
That's probably, it sucks in additional stress. I'm a pretty stress-free guy.
Are you?
Yeah.
You seem so. Yeah.
Thanks. So we got sidetracked on one of the questions. We did have a question about printing using washout material. So there are filaments that are water soluble. This makes great support material. So what you can do is you can actually print something that would require a lot of support if you have a two-headed printer, two extruders on it, one with your main material, your plastic material, and the other one with water soluble material. To do that, what you would do is you would, in SketchUp, create your model just however you want it, and in the slicing software, you would assign the model itself to the head that has the plastic, and then tell it to print any support material on the second head, which has the water soluble. I haven't actually seen this. I don't know that we have any of this material. I know we don't have any in-house right now, but I've heard it's a pretty cool way to print some real crazy models that need a lot of support. The downside, of course, to support is as you get it on there, you have to peel it all off or break it off, that sort of thing. With the water-soluble stuff, I guess you just drop it in water, let it sit for a while, and it all just kind of goes away.
Oh, cool.
Pretty cool.
So
Yeah.
I just thought of this. We're not sure how many of you are truly, very new to 3D printing, or how many of you are just tuning in. You already know a lot. But if you're super new to 3D printing and maybe just, go into a makerspace that's near you, and that might be a good place to watch somebody that's doing some 3D printing. Or if you've never been to a makerspace, they're popping up all around, and
Yeah,
might be a good place to kind of just jump in and see what people are doing.
It's pretty cool. Yeah, walk in there with your laptop with SketchUp on it, and everybody will already be impressed with you. All right, so just a couple more points about the competition. It will be the 28th of June at midnight. We will cut it off.
Mountain time.
Mountain time. That's right, here. The other thing I want to point out is one of the first things we'll do with these models when we download them is run Solid Inspector on them. So this is an opportunity to learn. If you haven't used Solid Inspector, make sure you run Solid Inspector and get a smiley face. If we run Solid Inspector and it comes up missing faces, has holes in it, anything like that, we're not going to go repair them. We're just going to say, oh, sorry, cool spinner, but you're out. So it's harsh. I know this is reality, guys. This is how the real world works. It's mean out there. So make sure you run Solid Inspector. Make sure this is a solid tool when you send it in. And it can have multiple pieces. It can have the main part, the caps, whatever you want to have, additional pieces to it. But they do all have to be immediately printable when we download the model. All right, so now we're looking for more questions. We've kind of covered all of the important stuff. As you guys have more questions, bring them on in. Let's see, Michael's asking about how to find the location of makerspaces. You brought that up, Josh. What you got to answer that.
Yeah, maybe a Google search. You know, there's a lot of them around now, and I think it shouldn't be too hard to find. And I think a
Yeah.
lot of them have websites. At least the ones I've seen do have some kind of website. Should be pretty easily searchable.
Yeah, no, they're not. There's not like it's not like looking up a specific chain of places. A lot of them are independent and
Yeah.
startups and that kind of thing. But yeah, I think if you were probably to go in and Google, the term makerspace has become kind of the standard space or name for those kind of places. So
Yeah.
if you Google makerspace in your town, you probably find some pretty quick and easy.
Yeah, there could be small ones that are just community driven, and maybe they're just starting up. But could
And
be,
some communities have